A very good afternoon to Dr. Ong and all my fellow friends. I'm Wai Keat from Group 12, and in this video I'll be showing the circuit simulation for figure 7.2, which is the emitter stabilized bias circuit as shown here, and also figure 7.3 voltage divider bias circuit as shown here. So without further ado, let's begin. So there are 3 resistors, 2 grounds, then voltage source, and an NPN transistor. So with this, we can connect it using wires. And the next step will be followed by change the new resistors to 2N3904, then set the DC voltage to 12 volt, and relabel it, then rename this to RC, then change the value to 2K, then relabel it with RE, change the value to 1K, then relabel this to RB, then change the value to 430K, and then run it with DC operating point. So here are the values. So just insert it to the this table. And now let's continue with voltage divider bias circuit as shown here. So this circuit requires 2 ground as well, then 4 resistors, and then a voltage source, and an NPN transistor. Now let's connect the components with wire. Then rename this to RB1 and change the value to 39K. then rename it to RC, change the value to 10K, and then change this transistor to 2N3904, then change this resistor to RE, the label to RE, change the value to 1.5K, and then change this label to RB2, and change the value to 3.9K, change this value to 12, and then label the point as C, put it here, then B here, and then E emitter to here. So with that, we can run it using the DC operating point. So here are the values that require to insert to this table. And that's all from me. Thank you. And I'll pass it to my lab mate, Mohammad Afiq, to continue with discussion and also conclusion.
Good evening, my name is Mohammad Afiq from Group 12. Today I will present about discussion and conclusion. The question 3 is, what is the use of emitter resistor RE in figure 7.2 and 7.3 when doing DC bias? By using RE, it will provide the required amount of automatic biasing needed for a common emitter amplifier that can be used to stabilize both the DC operating point and the AC gain. The question 4 is, which of these biasing circuit will you choose to design your common emitter amplifier? Here you can see the formula for stability. From the result, we can see as stability factor decrease, the stability of bias circuit increase. So, voltage divider bias circuit is more preferred to common emitter amplifier. For the conclusion, the emitter stabilization bias circuit is a configuration in which a bipolar junction transistor or a BJT is reinforced with an emitter resistor for enhancing its stability with regards to changing ambient temperature. The voltage divider bias is another configuration that can provide higher bias stability. Instead of using a negative supply of an emitter resistor, like two supply emitter bias, this configuration return the emitter resistor to ground and raise the base voltage. That's all from me. Thank you.